How do you find the inverse of a matrix? In this video, I'll show you how to do so for 2x2 matrices. Let's start with an example. Does the matrix A equals -1, -1, 1, 2 have an inverse? And if so, how can we find it? We need to therefore check whether there exists a matrix B, so that when I multiply A by B, either from the right or from the left, I get the identity matrix. So let's start with multiplication from the right. So A times this matrix ABCD needs to give me the identity matrix. But this 1 here, for example, is obtained by taking the first row of A and multiplying with the first column of B. So I find that minus A minus C needs to equal 1. Similarly, this 0 here must be obtained by taking the first row of A and multiplying it with the second column of B. So minus B minus D must equal to 0. And similarly for the next two equations. So here are the four equations that I'm going to end up with. Minus A minus C needs to equal 1. A plus 2C needs to equal to 0. And then two similar equations for B and D. So these first two equations can be used to solve for A and C. I simply add these two equations to each other. When I add minus A minus C equals 1 to A plus 2C equals 0, I find A minus A, which is 0, and 2C minus C, which is C. And on the right-hand side, I simply get a 1. And so that shows me C needs to equal 1. Well, once I know that C is equal to 1, since I have that A plus 2C is 0, 2C is 2, so A needs to be equal to -2. Similarly, I can use the second two equations to find that D must equal 1 and B must equal to -1. So altogether, I have found my matrix B. This -2 goes right here, the -1 is here, this 1 is right here, and this 1 is right here. Let's check that A times B indeed equals the identity matrix. So I need to multiply -1 times -2 plus -1 times 1. But -1 times -2, that's 2. -1 times 1 is -1. 2 minus 1 is indeed 1. Next, I have -1 times -1, that's 1, plus -1 times 1, so that's -1. That gives me a 0. And similarly for the bottom row. So indeed, A times B is the identity matrix, and you can also check that B times A similarly gives you the identity matrix. Therefore, A is indeed invertible, and we found the inverse to be -2, -1, 1, 1. In general, following a similar method, one can come up with a formula for the inverse of a 2x2 matrix. It turns out that if I multiply the two diagonal elements of A with each other and subtract from that product the product of the diagonal elements going in the opposite direction. So if I take AD minus BC, and if that results in a non-zero number, then A is invertible, and the inverse can be found by 1 over this number AD minus BC. And I take the matrix where D and A, those are the main diagonal elements, they have swapped positions, and B and C have stayed in their positions, but they have each gained a negative sign in front of them. So for a matrix, I swap the main diagonal elements, and the other two elements get a negative sign in front of them, and then I need to multiply the entire matrix by 1 over AD minus BC. So let's look at our previous example. The matrix A was -1, -1, 1, 2. So if I look at AD minus BC, I need to multiply these two numbers with each other. That's -2, and then subtract from that the product of these two numbers. 1 times -1 is -1. So -2 minus -1, that results in -1. -1 is not equal to 0, and so I know I can find the inverse by taking 1 over that number, and then taking the matrix where the two diagonal elements of A have swapped places. So 2 and -1 are right here, and the other two elements have retained their positions, but I need to swap their sign out. So 1 and -1. And if I multiply through by this 1 over -1 in front, this ends up being the matrix -2, -1, 1, 1, and that's precisely the matrix we found on the previous page. But here's another example. Now let's look at the matrix B equals 1, -1, 2, -2. If I multiply the two diagonal elements with each other, I get 1 times -2, and I need to subtract from that the product of the other two elements, so -1 times 2, and I find myself with a 0. So this matrix has AD minus BC equal to 0 rather than not equal to 0, and it turns out this matrix is not invertible. The number AD minus BC is called the determinant of A, also denoted det A. We have seen a 2 by 2 matrix A is invertible if and only if the determinant is non-zero. Let's look at some examples. Suppose A is the matrix 1, 2, 3, 4. The determinant of A is 1 times 4 minus 2 times 3. So 4 minus 6, that's -2, which is non-zero. And so A is invertible. The inverse can then be found by taking 1 over this determinant, so 1 over -2, interchanging the elements on the main diagonal, and putting negative signs in front of the elements that are remaining. On the other hand, B, which is the matrix -1, 3, 2, -6, has determinant -1 times -6, minus 2 times 3, so that's 6 minus 6, which is 0, and so B is not invertible. So we've seen a criterion that tells us whether a 2 by 2 matrix is invertible, and if it indeed is invertible, how to find the inverse.